I believe you can see my screen now.
Banana,
The person that is chopping banana, please. So, can we see my screen now?
About yes,
Okay.
yes.
my old banana.
That person that is really taking banana. Just make sure you send the banana to the whole class. Let's ration it. Now, basic concepts in statistics. Let us quickly define some of the basic concepts you will continue to come across in this course. Yes, they are very important because there is no how we talk of statistics that you don't be making mention of this concept. That is if you want to really talk like a statistician. Now, the first one is entity, which is the main thing you are dealing with. If you are going to study the accident rate on a particular road, our entity is that road. The example given of some primary school pupils, the entity, the pupils. So that particular thing, place or person that you want to do your or carry out your observation, what we actually do when we go out to collect data is we observe. Like that road now, we need to observe the movement of cars, maybe observe the road level. Do we have sharp bends? What are the things really causing the accident? So we are taking observations. So the entity is the person, place, or thing on which we make observations. Which means if you are asked that dash may be the person, place, and thing on which we make observation, entity. I don't know whether it's last semester or 2 semesters ago I taught this question like that, past question or so. If you have been checking past questions, you know what I'm talking about. Now, in studying the nutritional well-being of pupils in the primary school, the entity is a pupil in the school. I hope we are getting this. Look at it. So, what we went to study about is pupils. That means all of them that we have in the school, right? But an entity is just one of them, which means our commodity here is a pupil. Now, a pupil is just a representation of the pupils that we are dealing with. So that is what an entity means. Now, variable is another thing. Now, this is a characteristic that assumes different values for different entities. The weights of pupils in the primary school constitute a variable. Now, a variable can be numerical, it can be non-numerical. We should know that one. In fact, we have different types of variable. We are still going to talk about them. But you should know that the variable itself is what? A characteristic that assumes different values for different entities, which means while the pupil is the entity, that thing we are carrying out on the pupil, which is getting the weight and height of the pupil, is what we call variable. So we are checking the variable height and the variable weight of an entity, pupil. Okay, so let's talk about some types of variable. We have random variable. If we can specify for a given variable a mathematical expression called a function, which gives the relative frequency of occurrence of the values that the variable can assume, the function is called a probability function, and the variable a random variable. This one is somehow deep, so it's like we need to take it slowly so that we can understand. If we can specify for a given variable, we already know what a variable means now. That means, for instance, if, for instance, I want to work on the height of pupils in primary school, and I can specify a mathematical expression called a function. That means I can give a function for getting this height that I want to calculate or that I want to observe in the pupils, which gives the relative frequency of occurrence of the values that the variable can assume, which means this height, which is the variable that I'm working with on the entity pupil, if I can get a function, a mathematical expression, which we call function, to give the frequency of the number of times this particular height, let's say maybe we have 1.1 among the height, that it can occur, the values that the variable can assume, the possible value, the possible height that we can get from, okay, this is what we're trying to say. For instance, let's say that we know that no primary school pupil, for instance, will be 1.7. Is that not so? Let's say that the maximum we can get in primary school, just saying, is 1.5. In fact, that child is supposed to have been in secondary school by then. 1.5, right? And then, let's say the minimum we can get, maybe because of crèche and the rest. No, we are not even talking of nursery, primary school only. Let's say the minimum we can get is, let's say maybe 0.1, for instance. Let's just say 0.1. It means that if we want to give a mathematical expression, we say that this variable we are working on, all the possible, what do you call it now? Occurrence that we can have. That means this variable height that we are working on, all the possible occurrence we can have can only fall within the range 0.1 and 1.5. So if I'm to pick randomly any child, I already know that the height of that child cannot be 1.6. I hope you understand that part. That's what they're saying about random variable. There is a tendency of picking randomly from the variable that for instance, now we're working on the variable height on the entity pupil, and we know that the pupil, based on general knowledge, a primary school pupil should not be more than 1.5, for instance, just saying, and then not less than 0.1. So if I'm to pick randomly, I will know that no matter what I'm picking, it should not be less than 0.1, or whatever I will pick randomly can never fall less than 0.1 and more than 1.5, since the whole entity is within that range. That is what we're trying to say. And we'll call that probability. What I've just explained now is called probability. That means the probability of picking a child that is greater than 1.5 in this entity pupil of primary school is 0. It's not possible, because the maximum is 1.5. So having something greater than 1.5 is 0. So the probability of picking a child that is, let's say, if the highest highest known frequency is like let's say 1.2. Let's say most of them, after we've collected the data, most of them are 1.2, 1.2, 1.2. If 1.2 is the highest frequency, if we want to talk about the probability of picking 1.2, it will be very high. I hope we know that in probability, the highest number is 1. Who knows that already? That the higher, if something is so true that this thing is true, it can happen, is legit, the probability is 1. It cannot be more than 1. So probability falls between 0 to 1. That is, we have 0.1, 0.2, 0.3, 0.4, 0.5, up to 1.0. That is all. So if we say that the probability of picking a pupil that is 1.2, and let's say we did the observation now, and we did it on 100 entities, that is 100 pupils, and about 90 of them comes out to be 1.2 meters in height. If that is the case, if we want to talk about the probability of picking 1.2 from that set of entities, we will say it's very high. In fact, the probability will be as close to 1 as, let's say, 0.8 or so, which means the probability is very high. When the probability is getting close to 1, like 0.8, 0.7, 0.9, that means the probability of you randomly selecting a pupil from that school and the pupil will be 1.2 is very high. Why? Because most of the pupil in the school falls under 1.2. I think I've talked too much on that. Let's move on. So that is random variable. I will call that process probability. The process of you picking randomly based on frequency that you have already, that, okay, this is the highest number of occurrence, 1.2. So the probability of the chances of me picking from these occurrences is what we call probability, and then the variable is a random variable. Now, we have quantitative variable. When we talk about quantity, we are talking about countable numbers, figures. Now, this is a variable whose values are given in numerical quantities. They are given as numerical quantities. That is quantitative. Then we have another one, qualitative. But before we go to qualitative, let's take an example of quantitative variable. Examples of this is the hourly patronage of a restaurant. For instance, if you have a restaurant in your area and want to know how many people patronize the restaurant in 1 hour, when we take that experiment, what we are going to get is quantitative variable, because when we start counting, maybe we have 10 people that enter the restaurant in 1 hour. The result will be in figures, 10 entities or 10 people. So we have that as quantitative variable. I hope we already know what variable is by now. That was the first thing we talked about. Let me ask it as a random question. What is variable? So that we'll know if you're actually getting it.
Occurrence.
Is that really the meaning of variable? Let's try again. Yes, everybody should unmute. What is variable?
It's a characteristic of that assume different values. The characteristics of the different values of the entity.
Yes, you are on the right path. You are trying. Another person. Another person. It's only 2 misters that I have in this class.
Variable is characteristics
Okay.
that assume different value.
Variables, what I understand by variables, I can say variable might be the height or the weight.
Thank you. You are following. That particular thing you want to work on your entity, that thing you are looking for on your entity, that is in the layman definition. Those of you saying characteristic, you are correct. But I just want to see if you guys truly understand what variable means. For instance, we are going to a particular road to check the let's say the fatality of accident or the occurrence of accident on that road. What we are there to check is accident, occurrence of what accident. So our variable there is we want to get the fatalities that are happening. Is it fatalities I will call it actually, that are happening on that road over a given period of time that we want to make the observation. So please note that, because we have been mentioning variable almost every other thing now. We have been mentioning variable. If you don't know what the variable means, how will you understand all the random, quantitative, and qualitative that we're talking about? That's why I have to pause and go back so that you know that this is what variable means. That thing you want to check on your entity. In a very simple term, that thing that you are trying to check on your entity is that thing you are carrying out the observation on. Don't forget the experiment that you are trying to do. That thing you are doing it on, whether a person, a place, or a thing, that is what we call your entity. Why what you are carrying out on that particular entity is what we call a variable. That thing you want to know about your entity and you are observing on that entity is what we call variable. And we have talked about different types of it. Now we have the random, the quantitative, which is the one that has to do with figures, numbers, numerical values. Quantitative deals with numerical values. You see these two, I'm even sure some of you will meet it in TMA. These two, quantitative and qualitative, they give you definition and say which one of it is it. Is it quantitative or qualitative? So be ready. You have to understand the two. One, quantitative, that is quantity. It has to do with numbers, numerical values, or quantities. Example, the hourly patronage of a restaurant. This is the way they might ask the question. They say the hourly patronage of a restaurant is an example of dash variable. So in your options, you have qualitative, quantitative, random, and discrete. You are the one to choose which one is correct. The correct answer is quantitative. Now, qualitative variable. This is a variable that is not measurable in numerical form or that cannot be counted. Okay, somebody is raising hand. Hold on. Example of this are colors of fruits, taste of some brands of biscuit. When you have this kind of variables, they are not, you cannot count the color of fruit. It's uncountable now. So those one we call them qualitative variable. Okay, please go on, Gloria. What's your question?
Okay, good evening, everybody.
Good
Please,
evening, ma'am.
I have a simple question here. You said variable is the characteristic, that is the attribute of what we want to talk about, like the weight and
Yes,
the
yes,
height. Okay, so and this can we since quantitative variable is variable that has value
yes.
and
Numerical, numerical value.
can be counted numerical, have numerical
Yes,
qualities.
yes.
So can we now categorize them quantity weight and
Height. Your network. We can't hear you again.
height under quantitative variable?
Yes, you are correct.
Under
Yes.
quantitative
Yes,
variable.
yes. Those two, they are under quantitative variable. Once the end result of that variable will give you numbers, it falls
Okay.
under quantitative variable.
Yeah, thank you.
In fact, it's a very simple thing. Those ones that are qualitative, you will know. Look at it now, color of biscuit or color taste bud of the taste of a biscuit. You buy something, let's say a new drink was released last month, and then the taste of that drink is a qualitative variable. You understand? The taste of maybe food and the rest of them, color of things, all those ones, they are qualitative. When the result will give us something we can count, something that is numerical in form, maybe 10.0, 99.1, 1000, 200. When that is what your variable gives you, that kind of variable is quantitative. Now we have discrete. You should know that there will be some variable that will kind of fall in between quantitative and qualitative, but let's not go there yet. Now let's see what discrete variable means. This is the variable that can only assume whole numbers. You know that please, let's see the difference between quantitative variable and discrete variable. For quantitative variable, it can either be whole number or decimal number or any kind of number. Once it's just number, it falls under quantitative. But for discrete variable, it's only numbers that are whole numbers. That means like 2, 3, 1000, 2 million, 1 billion, that can fall under discrete variable. Like real things that we can count, like the number of humans on earth. We cannot have point something when we are counting human beings. We cannot have point something when we are counting humans. So those like human now, we call them those discrete means a variable that can only assume whole numbers. Let me ask us a question. Is a discrete variable also a quantitative variable? Yes or no? A discrete variable, is it also a quantitative variable? Yes or no? I'm expecting our responses. Eh?
It's quantitative.
It is quantitative. Okay. Is a quantitative variable a discrete variable? That is the other version. A quantitative variable, is it also a discrete variable?
Yes, sir.
No.
Yes.
It can
No. No.
and it can.
It is
No.
no.
No. You guys should follow it very closely. A discrete variable can only assume whole numbers. A quantitative variable can assume any type of number, whether decimal, fraction, or whole number. A discrete variable, so a quantitative variable can give birth to a discrete variable, but a discrete variable cannot give birth to a quantitative variable, because while one covers the whole type of numbers, the other one is just one type of number.
Okay.
So that is why discrete cannot give birth to quantitative, but quantitative can give birth to discrete. So I just try to clarify something there. So examples of discrete variables are number of local government council council areas of the state in
Sir.
Nigeria, number of female students in the various programs that we have in our school, National Open University. So when you start seeing this kind of examples and they're asking you what type of variable do they fall under, don't forget to discrete. Once your variable that you are given is only going to result in whole numbers, like feasible things that we can count, not like something that will have half or quarter, something that cannot assume half or quarter or three-quarter or any division. Those are discrete variables. A discrete variable has interruptions. It has interruptions between the values it can assume. For instance, between 1 and 2, there are infinite number of values such as 1.1, 1.11, and so on and so forth. They are called interruptions. They don't partake in the discrete variable, but they exist, but they are not part of it. But that will now lead us to another thing. Don't forget, so far we have talked about entity, variables. Then under variables, we are now talking about random variable, quantitative variable, qualitative variable, discrete variable, and even, and after that, we are now moving to continuous variable.
Continuous variable.
Now, what is continuous variable? This is a variable that can assume both decimal and non-decimal values. There is always a continuum of values that the continuous variable can assume. Now, the interruptions that characterize the discrete variable are absent in the continuous variable. Now, the weight can be both whole values or decimal values, such as 20 kilograms or 220.175 kilograms. I hope you understand the clear difference between continuous variables and continuous variables also fall under quantitative variables. You see, all other variables that have to do with numbers, they all fall under quantitative variables. It's just like saying quantitative variable gave birth to all of them. But I want to use a kind of comparison between continuous and discrete. Since discrete can only assume whole numbers, we can't compare it with continuous. But I don't want us to get it confused, because I know somebody will say that since continuous variable can assume both decimal and non-decimal, it's not supposed to be the same thing as quantitative variable. The reason why it's not the same is that continuous variable that we're talking about is one type of variable that can appear in two forms. It's not like a general number that whether minus, negative, positive, and the rest of them, all the type of numbers that we have. This one particular number or one particular value that can appear in two forms. If you are taking the weight of something, or the weight of something, you can measure somebody's weight that will be 17 kg. You can measure another person's weight that will be 17 point. All they are still underweight. So weight alone can be in two forms, decimal or non-decimal, depending on the person's actual weight when it's being measured. So those kind of variables that has tendency of appearing in two forms, like if you take somebody's own, it give you this type of number, which is whole number. You take another person's own, it give you decimal number. Those kind of variables are called continuous, which means it's not stable. Even I myself that you measure today, let's say I'm 50 kg. By tomorrow, if I have eaten well, or in the next 1 week, my weight is continuous. You may measure me in the next 1 week and I'm now 55 kg or even less than. So that is what we mean by continuous variable. What other variable do we think fall apart from weight? Give another example of variable that falls under continuous variable. We have a whole lot of them, but I want to see if you are following or if you understand what it means now. Which other variable falls under continuous variables? We even mentioned one of it again in
Height. Height.
height. Thank you. The height of a man today, a boy today, might be, in fact, your kids now, those of you that are already married and you have children, if you have all this scale in the house, you see them checking themselves, mommy, yeah, check today. Especially when you give children some nice meal, they'll think that the meal will work magic immediately and they'll gain height. So they want to be checking their height every day. Have I grown? Have I passed this place? Have I passed this place? So that means it is continuous. You are expecting them to grow daily. So let's leave all of that and move straight to population. Now, this is the largest number of entities in the study. In the study of how workers in Nigeria spend their leisure hours, the number of workers in Nigeria constitutes the population of the study. The population is the entire entity. You know what an entity means now? One part of that thing that you're actually working on. For the case of pupils in primary school, a pupil is an entity. So we know what entity means. But the overall entities that we're working on, we call them population. So the whole pupils that we have in that primary school, which constitute the data set or the entity that we want to work on, we call them the population of pupils. So the population of pupils in that school might be 200. One pupil is an entity. What we are working on is 200 entities called population. So I think we can move to sample. While we have population, we also have sample. This is the part of the population that is selected for a study. Do you know that if what we want to know is the average height of a primary school pupil in Nigeria, we will not need to go to all the primary schools in Nigeria to do the observation. We can select just, let's say we have 1,000 primary schools in Nigeria. If you carry it out on 100, this is what happens. The 1,000 primary schools in Nigeria is our population, number one. The 100 that we selected for our study, our observation, is called sample. Each pupil that we work on is called entity. I hope you get the difference now. The whole primary school in Nigeria is our target, so that randomly, if you are asked that, what is the average height of a primary school pupil in Nigeria, based on the statistics data that we have before that have been done, you can say that the height is 1.2. Let's assume. Why are you able to do that? Is it that you have gone to all the primary schools in Nigeria for you to know the height of a pupil or the average height? The reason why you are able to do that is that even though our concern is the average height of a primary school pupil in Nigeria, and we have several primary schools in Nigeria where we cannot go to all of them to get sample. So what we do is we select out of the population now is the 1,000 primary schools that we have in Nigeria. We select maybe 50 of them as samples. We work on the sample, and don't forget, each of the pupils that make up the sample is called an entity. So, for instance, okay, it's only written here, sorry. Let's say that in studying the income distribution of students in the National Open University, the incomes of 1,000 students selected for the study, now is having about 500,000 students, even more than 500,000 was far before. Now we are almost 800. So if you now want to check the income of all of us, you know how many years you used to complete that data. Although we have some technologies now that can make work fast, but let's just assume you are working manually. It's going to take time. So we'll just select a few of them, and then we use it to do our statistics, and at the end of the day, we'll say averagely a non-student is collecting 150 in a month. So the last one is random sample. This is a sample drawn from a population in such a way that the result of its analysis may be used to generalize about the population from which it was drawn. Okay. This will take us back to the definition of random variable. If you listen attentively when I was talking about random variable. I don't need to talk much on this random sample. It's the same concept. If we say that we are dealing with 1,000 schools that we have in primary schools that we have in Nigeria, and we selected 100. Out of those 100 that we selected, if you should pick randomly from them, let's say community primary school, Gaki in Abuja, if you should just pick randomly from them like that, and that one that you pick, you can also use it to generalize. That means you have a conclusion of the whole 100. That one becomes a random sample. That means I selected randomly. What we mean by random selection is, for instance, if I should put oranges in a basket, and I say dip your hand into the basket and pick one. You understand? Not like I told you, pick the orange that is pink in color. Let's say we have several colors there, and each of them is just one unit. That means one red orange, one green orange, one pink orange, one yellow orange. If I do not tell you that, pick a yellow orange, that one is different. If I just say dip your hands into the basket and pick any orange, what you are doing is you want to pick randomly. So it is by chance now that you pick any color. When you remove your hands up, the color that you pick was picked by what? Chance. That is why we talk about probability earlier on under random variable. This is what we're actually talking about too. When you just pick randomly from your sample, and that one you pick can also be, now when you, for instance, I think you don't know before that what is in the basket. Let's say it's a closed basket. If you don't know that what we have inside before is orange, by the time you remove your hands up and you see what you brought out, you already know that what is in that basket is what? Is a basket of orange. So I can now use it to analyze that, okay, this basket is containing oranges. So that is random sample. This is where we are going to stop tonight because I need to attend to some other things. You see, people have been calling me, I've been ending the course. So, but before we go, let's do a general class discussion. In fact, we're even done with this unit. I think in our next student-to-student class, we'll just go to another unit because it left about 3 units for us to study on our own. Now, what is the importance of statistics to human activities? Now that you have learned about statistics and so on and so forth. It's a general question. Let's answer it. What is the importance of statistics to human activities? You have the floor. Let's talk. Let's contribute.
Okay, sir. Can I talk?
Yes, sir. Anybody at all?
Okay, based on our studies tonight, I see statistics as an avenue whereby human can be able to make a rightful decision and the right choice as well.
Thank you, sir. The fact that you mentioned decision, you've made the point. If you don't know anything else about statistics tonight, you should know that they help us in decision making. Very important. So what you would have been going around to be spending money to do, you can just buy into the statistics data, or sorry, statistical data that we have already about that thing to predict what you want to predict on the thing. So you need to, because you have the mind to know the height of students in, or the pupils in primary school in Nigeria. You don't need to start visiting the whole primary schools now because it has been done before. There will be the data somewhere. Just search for it and you get the data. It helps you to decide, okay, this is the height of students, or sorry, pupils in primary school. So it saves you time in decision making. Okay. Do we have any other person that wants to say something on that importance of statistics to human activities? It's only decision making. Do we have any other thing?
I think, okay, let me try something again.
Okay, sir.
It helps in data collection, analyzing the data, and provide results that gives the necessary decision.
Thank you, sir. In fact, we almost forgot that part of the definition. Collection of data, is it categorizing the data, analyzing the data, and then presenting it? Yes. Now, if you have data, some of you even have some data in your hands that you don't know what to do with them because You don't have the knowledge of statistics. But when you know statistics, you'll be able to know that this thing I have in my hand is data, and I can actually work on it, polish it, and get something that someone else can use for decision making in his or her company or for future references. So thank you, sir, for that contribution. It's very important. Now, conclusion.
I'm not.
Okay, so no, yeah, come on.
I wanted to add to what he said. I said statistics can be used to organize and analyze data, which helps in managing risk. It also helps in managing risk
Exactly.
risk
Thank you. You made a very important point, man. It helps us in managing risk. If I don't, for instance, if I need some knowledge of some data and I don't know it and I don't have it, and we don't have some previous statistical work that have covered it, I will fall into the risk. But if I have, for instance, now, if they said that in June, mostly in June every year, this particular road used to record up to 50 incidents of fatal accident. If I have been planning to travel in June to pass through that road, what will I do? Based on the knowledge of statistics, I will say, abeg, let my journey be January or let it be August. Because statistics have shown or proven that that road is always busy in June. And so many lives are being lost in June on that road. So you don't take that risk again of traveling by that time. Or based on statistics, they say that tomorrow there will be tornado or snow will fall in Nigeria. If you know you can't survive such a temperature, you just stay in your house. You have been saved from some risk. Now, in conclusion, in this unit, you have.
Excuse me, sir.
Okay, I'm with you.
It also helps to improve accuracy.
Absolutely. Thank you for that, ma. It helps us in, overcoming some minor human errors that are obvious. So it increases the accuracy of our, let's say, data management or even management decision. If generally I am just brainstorming on my own and I'm just using my intuition to give a prediction, it will not be as accurate as predicting from statistical data that we have on ground. So the two predictions will be far different from each other. One will be more accurate because they have done research on that aspect before and gotten value, yes, they've gotten validative data on it. Is there another person that wants to say something before we actually conclude? We have just 1 minute left. Okay. You have learned a number of important issues that relate to the meaning and roles of statistics. Now, the various definitions and examples of concepts given in this unit will assist tremendously in the studying of the units that follows. In summary, what you have learned in this unit concerns the meaning and roles of statistics and the various concepts that are important to the study of statistics. Well, you can help yourself by answering this question later on when you get home. We don't have time again. Thank you all for attending tonight. This is a student-to-student class.
Thank you for your time, sir. We really
Thank you
appreciate
so
it.
much, sir. We really appreciate.
So have a wonderful
It's
night.
a good lecture.